This is Jack Jackson. We're going to be looking today at the Triangle Angle Sum Theorem. Now in our project that we did earlier, we took some triangles and measured their angles. So in Sketchpad here I have a general triangle which I can change by moving these vertices around and get triangles of any particular size. Now if I click on this button you can see their measurements. Measure of angle A here in green is 1.74 radians. B is approximately 0.55 radians, and C is 0.86 radians. If you add that up, that comes out to be about 3.14, or actually it's exactly pi radians. And notice that's not a coincidence. If we change this by moving it around, notice that these values do change, but the sum is always pi radians. Okay, seems like when I invert these as measuring them all backwards. Okay, but if we go down here, we get it measuring like this. Okay, and so here we can see this. Now we can actually prove this. Here's a proof. So the first step is to take through point B, draw a line parallel to side AC, and the parallel postulate says there's exactly one such line. Next we use what's sometimes called the Z postulate. You see kind of a backward Z shape right here, and we see that the alternate interior angles of this pair of parallel lines, and it's cut by a transversal, a line containing this line segment would go through both of those parallel lines, and these are called alternate interior angles. There's a theorem from geometry that says those alternate interior angles must be congruent. So those are the same size angle. And similarly, we have our Z. You can see the Z a little bit more clearly over here. From E to B to A to C is our Z, and the inside corners of that Z are the same. They're alternate interior angles. So if we call this first measure, let's call this measure X, the red one, and this X, and then we call the green one Y. So Y is the measure of A, and angle A and angle C is measure X. Now look what happens here. If you look right here, we have a straight line, and we have X plus Y plus this blue angle B. They all must add up to the same as the measure of a straight angle, which is pi radians, or 180 degrees. And so there's our Z, but we know X plus Y plus Z equals pi, or 180 degrees, because this dBE means B is between D and E, and you have means you have a straight line there. And so we see that it has to turn out to be a straight line. So bottom line is the angles of any triangle must add up to pi radians, or 180 degrees. That's called the Triangle Angle Sum Theorem. And that's going to be the first of our really big results that we're going to have about measurements in triangles. Of course, trigonometry is the study of the measure of triangles. This is our first big trigonometric result, which says if we know two angles in a triangle, then we can figure out what the third one is pretty easily using this result.